So the one that is in the middle is 3 or 5?
I'll explain that. In the middle, this should be, right here, should be in your notes. Okay? And you can have it as X or as alpha. Okay? So, but they need to be in your notes. This is a 30, 60, 90. Okay? Because of the 90. This is a 45, 45, 90.
Wait, can you have your paper?
Okay? And these should always be in your notes. From these, you will determine, are you going to use it on this one? Are you going to use this or this? Okay? So, of course, if this is a 30, 60, 90, you'll use a 30, 60, 90. If this is a 45, 45, you'll use the 45, 45. And if you look on number 3, it says that this is 30. Right? And this is a right triangle. That means that this has to be 60. Right? So I have to add up to be 180. And if this is 90, then these have to be 90. So 30, 60, 90. Alright? So that means we're going to use this guy. But to use that guy, we're going to rewrite it so that it looks just like this one. Does that make sense? We want it to look just like this one. Okay? So, this is the hypotenuse. So which one is the hypotenuse? X, x square root 3, or 2x? Which is the hypotenuse? 2x. Okay? Alright, which one is the short leg? This one or this one? X or x square root 3? Which one's shorter? X. That means this is x square root 3. Does that make sense?
Yes, sir.
Alright. So let's get it done. Alright, so now I got to look at whatever the number is that they give me. Whatever they give me, and I'm going to make that equal the same side of my triangle, my special triangle. And the same side would be this, right? So these have to be equal. Okay? So that means that 2 square root 3 is equal to x. Okay? And that's number 1. Why?
Special triangles?
That's right. Definition of special triangles. Theorem, if you want to write that. Okay? So that's our special triangle theorem. Okay? So, I know what x is. That's great. So I get to move to the next one. And I'm going to change my color. And I'm going to say, okay. So which one do you want to deal with? A or B?
A.
A. Okay? So which one is A? This guy or this guy?
2x.
2x. Okay? So that means that step 2 says A is equal to 2x. Fair enough? Why? Remember, if something is special to you, okay, then you use that something to help you through the problem. Okay? These special triangles are going to be very helpful if they're in your notes. Okay? Better if you memorize them, but very helpful if they're in your notes. I should be able to see that these are connected. So I can say those are equal, and the reasoning, same here. Definition of special triangles. That's all. Because the special triangles theorem says that those sides that correlate are equal. Those sides that correlate are equal. And these correlate to each other. That's all we're saying. Alright. So what's x? Did we figure out what x was?
Yeah.
What is it?
2 square root 3.
2 square roots of 3. So that means we can plug that in for x, right? Okay? So that means that A is equal to 2 times 2 square root 3. Okay? Now what's outside multiplies what's outside, but what's inside multiplies what's inside. That's what I tell students. Outside to outside, inside to inside. Okay? What I mean by that is, if it's in a radical, it multiplies inside the radical. But if it's outside a radical, it multiplies to what's outside the radical. So 2 times 2 is 4. Okay? Now what lets us get to this point though? What's our third step here?
Substitution.
Substitution. Good. And so then we're going to go, okay, then a is equal to 4 square root 3 because 2 times 2 is 4. And what's that called?
Simplify.
Simplify. Okay? Then I'm going to change my color. I know what A is. A is 4 square root 3. Okay? Now I'm going to find what's the last thing I need to find? B. Okay? And what's B?
X squared 3.
X square root 3. Very good. B is x square root 3 because it's that other side. That's that side correlating to it. Okay? Alright, so B is equal to x square root 3. Right? Alright. Y.
Special triangles.
Very good. Definition of special triangles. Okay? Then what?
Substitution.
Substitute. So what's x?
2 squared.
Yes. So x is 2 square root 3, right?
Yeah.
So that comes down and in.
Correct.
And this is just the square root of 3, right? Okay? So now we're saying 2 square roots of 3 times the square root of 3. And remember what I said. Inside is multiplied against inside, outside against outside. Right? So, what's 3 times 3? 9. So what happens here, and you guys said that was substitution, right? Okay, so then you have B is equal to 2 square roots of 9. But think about that. Think about that. Isn't 2 square roots of 3 times 3, doesn't the 3 get pulled out and it's 3 times 2? Right? Because what is the square root of 9? 3. So it's 2 times 3, which is 6. So B is equal to 2 times 3, which is equal to 6. And what do we call that? So this was simplify, and this is also simplify. Okay? So B is 6. And that's number 3. Right? Number 4 is even easier. But it's different.
Number 5.
Or I mean number 5, sorry. So number 5, it is a 45. So we are using this one. Okay? But we need to rewrite it so it looks like it. So I need to draw this. And then I know, okay, I always start with my hypotenuse. Okay? And the hypotenuse is across from the right angle. So which one is the hypotenuse? X square root 2, right? And then what are the other two sides? X. I know this is 45 and 45, right? So what's happening here is, okay, well, then wouldn't X equal 4? Is that true? Why would X equal 4? Why? Why does X equal 4?